सो हेलो नमस्कार टू द ऑल केमिस्ट्री लवर्स, डॉक्टर्स एंड इंजीनियर्स ऑफ द नियर फ्यूचर। मैं विजय कुमार सोनी आपका हार्दिक स्वागत करता हूं इन केमिस्ट्री वाला चैनल रिगार्डिंग टू योर वन एंड ओनली केमिस्ट्री। In previous video, we have discussed about the just preparation methods of the ether. There are a lot of methods to prepare the just ether as a diethyl ether or just ethyl methyl ether or dimethyl ether, means as a symmetrical and asymmetrical ether, may as aliphatic and may as aromatic also. Now the time to discuss about the physical and chemical properties of the ether. So first of all, we'll go with the physical properties of the ether, which are very important for us. So this is the heading of this video. First heading: physical properties. Physical properties of ether. If we will go with the just physical properties of ether, then first of all, we'll go with the physical state and order. You can say physical state. Regarding to the physical state, just lower member. What are the lower member? One of the is your dimethyl ether and ethyl methyl ether. This is the C2H5. Except these two, because of these two compounds are, you can say, gases. Rest all ethers are volatile liquids with present order. Means these gives pleasant odor, just you can say sweet smelling compound. After then we'll go with the second property. What is that? That is the dipole moment. This is the dipole moment. If we will go with the dipole moment, just we can say this is the alkyl group in ether and this is the OR. Electronegativity of the oxygen is larger than the just alkyl group. So here will positive and here will negative charge, partial negative charge. What we can say? We can say that ether are polar in nature. And as we all know, polarity is defined in the term of dipole moment mu is equals to Q into D. Just molecules having this property mu dipole moment are polar, while which doesn't exist they are known as non-polar. So we can say ether is a polar in nature, means it exists just dipole moment. If we will go with the further, then between two ether molecules, this is the one of the molecule, this is the another molecule, this is another third molecule, this is the R dash. Both alkyl group are different, maybe or maybe same. So due to polarity, here will partial negative charge, positive, again negative, again positive, again negative, again positive. Here will a specific kind of the bond over here and over here. This kind of the bonding is called as dipole, because this acts as a dipole. So here will dipole interaction, dipole interaction force. This was about the just regarding to the polar nature. If we will go with the just two of the important example, one of the is your methoxymethane and another is your ethoxyethane. This is the methoxymethane, and this is your ethoxyethane. If we will go with the just dipole moment, then here is the most important thing. The value of dipole moment for the dimethyl ether is your 1.30 dBi, and for this it is your 1.18 dBi. Means on increasing bulkiness over the oxygen atom, just dipole moment decreases. This is the most important. So we can say on increasing just molecular mass, we can say molecular mass, dipole moment, dipole moment decreases, polarity decreases. This was regarding to just two properties as a dipole moment and physical state. Now the time to discuss about the third important property, that is about the boiling point. This is the third property as a boiling point. Boiling point. No doubt, ether are polar in nature, but their dipole moment is so low. So we can say that due to having just a slight lower dipole nature, polar nature, and absence of hydrogen bonding, these have this low value of the boiling points than their alcohol, but higher than the just alkenes. Similar difference, ज़्यादा difference नहीं होता particular हाइड्रोकार्बन और ईथर के बीच में. Regarding to alcohol, what will be? Just we can say due to having due to having weaker polar nature and absence of H bonding, just exists ether exists low value of boiling point, then their alcohol. This was regarding to the boiling point. If we will go with the further fourth property, then that is your solubility. Solubility. Just lower ether. Lower ether means dimethyl ether, or you can say methoxymethane, and just ethyl methyl ether means methoxyethane. Lower member, lower member can form H bonding, H bonding with water. So these are soluble in water. If we'll go with this further, then on increasing molar mass, just you can say solubility decreases on increasing molar mass. Molar mass. How? Then we can explain it by using following diagram. This is the ROR. This is the HOH. This is the H and OH. This is H. Here will H bonding, partial negative charge, 2 as a partial positive plus. This is the H bonding. Intermolecular H bonding will be present. That's why these are soluble in water, while on increasing molar mass, the solubility of the ether decreases. So these are the important properties of the ether. You have to take just very important, because of it will be some of the questions from this kind of the slide also. Polar nature is the most important property. Now the time to discuss with the further. Just we can say about the further means ether are used as a weak polar solvents to dissolve the organic substances. This is a very important compound. Such you can say these are used in Wood's reaction, Wood's simple, Wood's fatigue, and just fatigue reaction in the formation of the different organometallic compounds like Grignard reagent, a lot of super Grignard reagent, so on. If we will go with the further, just regarding to the physical properties, we can take one of the important property as we have taken just a physical state. After then we have taken just a dipole moment. Third is your boiling point. Fourth is your just solubility, and fifth is your density. This is the fifth property, density. Here will only one of the question. These are ether are lighter than water. Water से lighter है particular. First thing. Second thing is your ether are also used as just anesthetic compound. Anesthetic compounds also. This was about the physical properties of ether. Now we'll go with the just chemical properties of the ether. So this is about the chemical properties of ether. Chemical properties of ether. If we will go with the just chemical properties of ether, then here is the structure of ether, ROR. And regarding to this, there will following properties as a chemical properties. First of all, we'll go with the reaction of due to lone pair of oxygen atom. This reaction is also called as reactions of etherate oxygen. Reactions of etherate oxygen. If we will go with the second property, then we can take reactions involving cleavage of CO bond. We are having the just cleavage of CO bond. Now we'll go with the further third property, reactions due to just alkyl group. First reaction due to etherate oxygen, second with the cleavage of this bond, and third is reaction due to alkyl group. This was about the third property. If we'll go with the fourth property, then as a fourth properties we can say are some of the other reactions of the ether like combustion, so on, other reactions. And fifth properties will be as a electrophilic substitution reactions, which are the very important for the topic, and it will be a lot of questions from here. So if we'll go with the first property, reactions due to etherate oxygen. Reactions due to etherate, etherate oxygen. Then here will first property, formation of formation of just peroxide, or you can say reaction with air, reaction with air. अगर पर्टिकुलर आपने ईथर को एयर में खुला छोड़ दिया या एयर टाइट नहीं किया उसकी बॉटल को, then what will be, it may explosion. Why? Suppose you have just diethyl ether like this, CH3, this is the CH2, CH3, CH2O, this is the CH2 and CH3. If there is the presence of air in the light, then here will formation of following compound, CH3, CH2, this is the O, this is the C, CH3, this is your H and OOH. This is the 1-ethoxy, 1-ethoxy ethyl hydroperoxide, hydroperoxide, which further decomposes in just, it's an explosive compound, explosive compound. So it on combustion, on explosion gives CO2 and S2. If we will balance it, then just 1, 2, 3, 4 carbon atom. So 4 of CO2, hydrogen 3 to 5, 2 7 and 3 10. So 5 of S2O, 4 2s are 8 oxygen and 5 oxygen 13. So we can take just 13 of O2 means 26 oxygen. So we can say 13 by 2. 13 by 2 means it will approximately 7 to the 14 and 1. This is the 4 to the 8 and 5 13. 6 to the 12 and 1 13 will be as a formation of CO2 and S2. क्वेश्चन अराइजेस, क्वेश्चन आता है कि साहब हमें कैसे पता लगेगा कि गिवन सैंपल आपके पास में एक्सप्लोजिव है या नहीं है, या इम्प्योर है, या पेरोक्साइड का फॉर्मेशन हुआ है या नहीं हुआ है. तो इन दैट काइंड ऑफ सैंपल, जस्ट जहां पेरोक्साइड का फॉर्मेशन हुआ है, ईथर, ईथर विद द पेरोक्साइड, पेरोक्साइड, उसमें हम फर्स्ट ऑफ ऑल फ्रेशली प्रिपेयर्ड FeSO4 ऐड करेंगे. FeSO4 आपके पास में सॉलिड होगा, उसको आपको वाटर सैंपल में लेकर उसमें डिजोल्व कर लेना है. नाउ दैट इज कॉल्ड एज फ्रेशली प्रिपेयर्ड FeSO4 बिकॉज ऑफ, अगर आप पहले से बना हुआ FeSO4 काम में लेंगे तो उसका ऑक्सीडेशन हो गया होगा, देन Fe+2 चेंजेस इन Fe+3, सो रिजल्ट्स नहीं आएंगे. एंड आफ्टर देन वी विल ऐड पोटेशियम thiocyanate. On reaction with these substance, this peroxide ether gives red solution, red solution of FeCNS whole thrice. ये रेड कलर का सब्सटेंस बना लेता है. सो दिस वाज अबाउट द जस्ट पेरोक्साइड. इट्स वेरी इंपॉर्टेंट रिएक्शन कि पर्टिकुलर एयर टाइट रखना चाहिए. लाइट के एब्सेंस होने के लिए डार्क कलर की बॉटल्स में ईथर को रखा जाता है. ये क्वेश्चन कई बार पूछा जा चुका है और इसका पर्टिकुलर टेस्ट कैसे करते हैं वो भी इंपॉर्टेंट चीज है, काफी हद तक पूछा गया है. Now the time to discuss about the further how we can remove the form peroxide. जो peroxide formation हो चुका है उसको remove कैसे कर सकते हैं? It will be one of the question. So by using, this is the, by using aqueous Ki solution, aqueous Ki solution, we can remove the peroxide from ether. ईथर से peroxide को remove कर सकते हैं, and Ki changes in I2 and it makes the pure to the ether. This was about the just your first part as a reactions of the etherate oxygen. Regarding to just etherate oxygen, it will be just 2 or 3 example also. What are they? Listen me carefully. This is the B part. This is the B part. Formation of oxonium salt, or you can say a reaction with mineral acids. If you are going to take just any kind of the ether, ROR, then due to presence of lone pair of electron over the oxygen, whenever it reacts with the HCl or H2SO4 like this, it gains the proton of that kind of the acid, and we have discussed in 11th, which gains proton, they acts as a Lewis base. So here will formation of ROR with a single lone pair, and here will bond with the hydrogen, positive charge over the complex, and here will Cl minus. Here will your ROR, one of the lone pair, this is the H, this is the plus, and HSO4 minus. You will say just oxonium hydrochloride, dialkyl oxonium chloride, and here will formation of dialkyl. You can take ethyl, diethyl also, similar to that kind of the reaction. Dialkyl oxonium hydrogen sulfate as a just here will formation of the salt. These are the salt. If we will go with the further, then we can take one of the important example also regarding to the just etherate oxygen, or you can say about the Lewis basic nature of ether, and the reaction is just here by using some of the Lewis acid का यूज करके हम पर्टिकुलर इस प्रॉपर्टी को एक्सप्लेन कर सकते हैं. सो दिस इज द Lewis बेसिक नेचर. पर्टिकुलर ईथर की Lewis बेसिक नेचर को शो करने के लिए, एक्सप्लेन करने के लिए वी कैन यूज ROR प्लस BF3. BF3 का ऑक्टेट कंप्लीट नहीं है, आउटरमोस्ट शेल में 6 इलेक्ट्रॉन है. We can use ROR ether, and these are the two lone pair. Aluminum chloride, ROR, and FeCl3, ROR, and this is the Grignard's reagent, This is the RMgX. If we will go with this kind of the reaction, then here will formation of the salt ROR donates one of the lone pair like this in the form of coordinate bond. Boron trifluoride etherate, boron trifluoride etherate. We'll discuss here will one of the important question also. This is the ROR aluminum chloride etherate. Here will ROR one of the lone pair ferric chloride etherate. What will be here? One of the question. And another question, what will be the change in hybridization state during these reactions? Think about it. I'm giving you just some of the second to think about it because of it's too important, my dear, as I told you. If it is not clear by you because of it's a part of 11th standard. So what will be? First of all, we'll go with this kind of the reaction. We'll take just two molecules. Here's the Mg, here's the R, here's the X, here is the R2O, R2O, one of the molecule. This is the another R2O. It donates one of the lone pair like this. It also donates one of the lone pair like this. So this formation of the salt, these entire reaction shows about the basic nature of ether due to having capacity to donate lone pair of electron, it behaves like a Levi's base. तो ये Levi's theory के along आपने along में discuss किया है. One of the important question also. Here is hybridization sp3. Here hybridization is sp2. But if we'll go with this kind of the substance, then here hybridization is your sp3 and here will again your sp3. Because of ये पर्टिकुलर जो अपना लॉन पे डोनेट कर देगा, शेयर करेगा इसके साथ में, डोनेट करने के लिए कोऑर्डिनेट बॉन्ड बनाएगा, तो पर्टिकुलर इसका भी ऑक्टेट कंप्लीट हो जाएगा. सो sp3 2 से sp3 हाइब्रिडाइजेशन होगा. ये क्वेश्चन आ चुके कई बार 11th में भी एनसीईआरटी में पूछा गया है और कॉम्पिटिशन एग्जाम में कि इफ देयर इज द एनी चेंज इन द हाइब्रिडाइजेशन देन यू विल से oxygen remains same, but the central atom of the Levi's acid as a B, Al, Fe and Mg changes from the sp2 to sp3 as a hybridization state. So this was about the first part of the chemical properties regarding to the just oxygen atom of the ether, or just you can say etherate oxygen. So all the doctors and engineers will meet in the next video with just a new topic, another chemical properties of the ether. And these three chemical properties are very important regarding to the just chemical properties of the ether and especially in Levi's basic nature of the ether. We'll meet in the next video with a new topic. अपना ट्रस्ट, अपना विश्वास यूं जताते रहिए. फिर मुलाकात होगी. तब तक के लिए शुक्रिया. धन्यवाद.